Here's a lesson for section 4.3, solving equations involving fractions. So up until now we've learned how to solve 1- and 2-step equations, solve multi-step equations, and now we're going to learn how to solve equations involving fractions. The first part we're going to do is we're going to learn how to solve equations involving one fraction. So if you remember back to last lesson, I told you whenever we have brackets, we want to get rid of them in the first step by distributing the term out front. So use our distributive property to multiply a third by 8 plus x to get rid of the brackets. Okay? That's what we did when the term in front of the brackets was not a fraction. When the term in front of the brackets is a fraction, it'll actually make the question more complicated if we distribute that 1/3 to the 8 and to the x. Then we're going to have even more fractions that we're going to have to deal with. What you want to do whenever you have a fraction in a question is try and get rid of the fractions in the first step if you can. And the trick to getting rid of a fraction is to multiply both sides of the equation by the denominator of the fraction. So the denominator of this fraction is 3. If I multiply both sides of this equation by 3, I'm allowed to do that because that'll keep the equation balanced. As long as I do the same thing to both sides, I can do anything I want and it'll keep the equation equivalent. So multiply both sides of the equation by 3, and then this fraction will be gone. So I'll show you how that works. So I'm going to multiply the left side by 3, and I'm also going to multiply the right side of the equation by 3. And keep everything else the same. So now I have 3 times 6 on the left, and on the right I have 3 times a third times 8 plus x. So now if I simplify, 3 times 6 is 18. 3 times a third, okay, I have a 3 divided by a 3. Those cancel, and what I'm left with is just a 1. So I have 1 times 8 plus x. 1 times 8 plus x. 1 times 8 plus x is just 8 plus x. So 18 equals 8 plus x. Now, solve this equation just like I would have solved any of the equations in the previous lessons. Isolate the variable. So move this positive 8 to the other side. It'll become minus 8. So I have 18 minus 8 equals x. 10 equals x. So x is equal to 10 is the solution to this equation. 10 is the value of x that would make this equation true. Okay? And you could check your answer by plugging in 10 for x and make sure left side equals right side. So if I plug in 10 for x, I would have 8 plus 10 is 18. And then a third of 18 is 6. So the left side would equal the right side. Number 2. So I've got a big fraction here. I have 7 times x minus 5 over 4 equals 7. I want to get rid of this fraction in the first step. I know to get rid of a fraction, I just have to multiply both sides of the equation by the denominator. The denominator is 4, so I'm going to multiply the left side of the equation by 4. So I have 4 times 7 times x minus 5 over 4 equals 7 times 4. So I multiply the right side by 4 and the left side by 4. So I have a 4 times this. So 4 times 7 times x minus 5 over 4. So I have a 4 divided by a 4. Those are going to cancel. And what I'm left with is just 7 times x minus 5 equals 7 times 4 is 28. Now solve this like in the previous lessons. Get rid of our brackets by distributing the 7 to the x and the negative 5. And I get 7x minus 35 is equal to 28. Now remember, what you want to do first in this situation is you want to get the term that has the variable all by itself on one side of the equation. So what I'm going to do is I'm going to move this minus 35 to the other side of the equation. So the opposite of subtracting 35 is adding 35. So on the other side of the equation, it's going to become 28 plus 35. And then 28 plus 35 will give me 63, so I can simplify that. So 7x equals 63. And then if I divide that by 7 to get the x by itself, I get x is equal to 9. Okay, so I had 7 times x equals 63. To move this 7 to the other side, I do the opposite of multiplying by 7, which is dividing by 7. And 63 divided by 7 is 9. Okay, and you can plug that back into your question and make sure that that's the correct answer to this equation. make sure that 9 is the value of x. It makes the left side equal the right side. And if you plug it back in, you will get 7 equals 7, which means left side equals right side. Therefore, that's the correct answer. Number 3. So once again, you've got a question here that involves a fraction. Do not distribute the fraction to get rid of the brackets. It'll make the question more complicated. Okay. First thing we want to do, let's try and get rid of this fraction right off the bat by multiplying both sides of the equation by the denominator of the fraction. So multiply the left side by 6. And let's multiply the right side of the equation by 6 to keep it balanced. Now I have 6 times 1 over 6. So I have a 6 divided by a 6. Those cancel. I'm left with just 1 times 2x plus 4 equals 5 times 6, which is 30. 1 times 2x plus 4 is just 2x plus 4. Isolate the term that has the variable, so isolate the 2x by moving the plus 4 at the other side. It becomes minus 4 on the other side. So I get 2x equals 26. Now I have 2 times x equals 26. Isolate the x by doing the opposite of multiplying by 2, and that is dividing by 2. And that tells me that x equals 13. That's my solution. Don't forget that you can check that solution by plugging it into your equation and making sure that's the value of x that makes the left side equal the right side. Number 4. Alright, so now we're going to do some questions that have more than one fraction. So you want to follow the same principle. You don't want to distribute the fractions to get rid of the brackets. You want to get rid of these fractions right off the bat. In order to get rid of the fractions, if there's more than one fraction, what you need to do is you need to find the lowest common denominator between the denominators of all the fractions. So I have a denominator of 3, a denominator of 4. The lowest common denominator of 3 and 4 is 12. So I need to multiply both sides of this equation by 12. So multiply the left side by 12 and multiply the right side by 12. And then when you simplify this, the fractions will be gone. So I have a 12 times a third. So I have a 12 divided by 3. 12 divided by 3 simplifies to 4. And on this side of the equation, I have a 12 times 3/4. So I have a 12 divided by a 4. 12 divided by 4. That simplifies to 3. So here I have 4 times 1, which is 4. I need to multiply that by 2x minus 5. And here I have 3 times x minus 2. 3 times 3 is 9. I need to multiply that by x minus 2. Now we can get rid of our brackets because the number in front of the brackets is no longer a fraction. So let's distribute the 4 to the 2x and the negative 5. And I get 8x minus 20 equals, on this side, distribute the 9 to the x and the negative 2. 9x minus 18. Now what you want to do is you want to move all of the terms that have the variable to one side of the equation and move all the constant terms to the other side of the equation. So I want to have the 8x and the 9x on the same side of the equation. I'm going to bring them, well, for consistency, I'll just bring them to the left for this time, okay? And I'll move the constant terms to the right. So on the left, I already have an 8x, and I need to bring this positive 9x to the left. It's going to become minus 9x. And on the right, I have negative 18. I need to bring this negative 20 to the other side. So on this side, I'm subtracting 20 to bring it to the right. I must add 20. And what I have, collect my like terms, 8x minus 9x gives me negative 1x. And negative 18 plus 20 is 2. Now I need to actually isolate the variable. I need to isolate the x by moving the negative 1 to the other side. On this side, I have negative 1 times x. The opposite of multiplying by negative 1 is dividing by negative 1. So to get that negative 1 to the other side, I must divide by negative 1. So x equals 2 divided by negative 1. 2 divided by negative 1 is negative 2. And that's the solution to this equation. Don't forget you could plug that back into your equation and make sure this is the value of x that makes the left side equal the right side. Number 5. Once again, another equation that has two fractions. First step, whenever you've got fractions, is try and get rid of the fractions. Don't distribute this 1 over 5 to the 7x and negative 3 to get rid of the brackets. What we want to do, get rid of the fractions by multiplying by the lowest common denominator of all the fractions. So my denominators are 5 and 10. The lowest common denominator between 5 and 10 is 10. So what I'm going to do is I'm going to multiply both sides of the equation by 10. So multiply the left side by 10, and multiply the right side by 10. And once I simplify this, my fractions will be gone. So I have 10 times a fifth. So 10 divided by 5 simplifies to 2. And on this side of the equation, I have a 10 times 1 over 10. So I have a 10 divided by a 10. 10 divided by 10 simplifies to 1. So what I have 2 times 1, which is 2. I still need to multiply that by 7x minus 3. On this side of the equation, I have 1 times 1, which is 1. Now let's get rid of our brackets by distributing the 2 to the 7x and the negative 3, which gives me 14x minus 6 equals 1. Now isolate the variable term, so isolate the 14x by moving this negative 6 to the right, and it will become plus 6. So I'll have 1 plus 6. So I now have 14x equals 7. Now isolate the variable by moving this 14 to the other side. So I have 14 times x. The opposite of multiplying by 14 is dividing by 14. So divide the 14 to the other side. I have x equals 7 over 14. And I know 7 is half of 14. So in simplest form, this is 1 over 2. 7 over 14 equals 1 over 2. So x equals a half is the solution to this equation. And don't forget, you could plug that back into your equation for x and make sure this is the value of x that makes the left side of this equation equal the right side. Number 6. So another equation where we have two fractions that we don't want to distribute, because if we distribute these fractions, it's going to make this question a lot more difficult. What we want to do is just get rid of the fractions right off the bat. I know I do that by multiplying both sides of the equation by the lowest common denominator of 4 and 5. So my denominators are 4 and 5. Find the lowest common multiple of 4 and 5. If you can't find it just by thinking about it, count by 4s, count by 5s, find the lowest common number between those two lists. So let's find out. So 4, 8, 12, 16, 20, 24, and so on. And if I count by 5s, 5, 10, 15, 20. Okay, so I found one that they have in common. The lowest one they have in common is 20. A nice little trick you can use, if you can't think of a common denominator between two numbers, multiply those two numbers together, and that will give you a common denominator. It might not necessarily be the lowest common denominator, but it will be a common denominator. And in this case, 4 times 5 is 20, and that, in this case, is the lowest common denominator. So what I'm going to do, I'm going to multiply both sides of this equation by 20, and that will eliminate the fractions. So multiply the left side by 20. And then also, I'm going to get rid of this stuff so it's not in the way. Multiply the right side by 20. And then once we simplify, our fractions will be gone, and this question will be a lot easier to do. So I have a 20 times negative 3 divided by 4. So I have a 20 divided by 4. That simplifies to 5. And on this side of the equation, I have a 20 times 4 over 5. So I have a 20 divided by 5. That simplifies to 4, because 20 divided by 5 is 4. Now our fractions are gone. We can start simplifying and solving our equation for our variable d. So I have a 5 times negative 3 times d plus 3. So 5 times negative 3 is negative 15. I need to multiply that by d plus 3 still. And on the other side of my equation, I have a 4 times 4 times 3d minus 2. Well, 4 times 4 is 16. And I still need to multiply that by 3d minus 2. So let's go ahead and do this now. Let's get rid of our brackets by distributing the terms out front using our distributive property. So distribute the negative 15 to the d and the 3. Negative 15 times d is negative 15d. Negative 15 times 3 is negative 45. Now, on the other side of the equation, let's eliminate our brackets as well using the distributive property. So let's distribute our 16 to the 3d and to the negative 2. So 16 times 3d gives me 48d. And 16 times negative 2 gives me negative 32. Now we need to collect all our variable terms to one side of the equation and all our constant terms to the other side of the equation. What I'm going to do this time, I'm going to collect my d's to the right this time, just so we remember that we can collect our variable terms to either side of the equation. And if you notice, when I collect my d's to the right, I'll have a positive value of d already, which is nice. Okay? So let's collect our variable terms to the right and bring all the constant terms to the left. So what I'm going to do on the left, I'm still going to have negative 45. I'm going to bring this negative 32 to the left. It'll become plus 32. On the right, I have 48d. And I'm going to bring this negative 15d to the right. It's going to become plus 15d. Now I'm going to simplify this. So negative 45 plus 32 will give me negative 13. And 48 plus 15 will give me 63. D. Now what I want to do, I want to actually isolate the variable. So what I'm going to do is I'm going to divide that 63 to the other side of the equation. And what I'm going to have, I'm going to have negative 13 divided by 63 equals D. Okay? And that's in simplest form. 13 is a prime number, so I know nothing other than 1 or 13 goes into 13. And 13 doesn't go into 63. So I can't simplify this any further. So that is my answer to this question. And you could plug that back into your equation and make sure that's the value of d. Makes this equation, the left side of this equation, equal the right side of this equation. Okay. So just keep in mind, remember, if you get a big fraction like this, it doesn't mean that you've done the question wrong. Fractions are perfectly valid answers. Okay. Number 7. So I'm going to teach you 2 ways to do a question that's in this form. The first way is the same way we did the questions before. We've got 2 fractions, one with a denominator of 3, one with a denominator of 5. Find the lowest common denominator of these 2 fractions. And in this case, the lowest common denominator is the product of 3 times 5, which is 15. So multiply both sides of the equation by that lowest common denominator of 15. So I multiply the left side by 15. Now I need to multiply the right side by 15. And once I simplify this, my fractions will be gone. So I have a 15 times k plus 2 divided by 3. So I have a 15 divided by 3. That simplifies to 5. On this side, I have 15 times k minus 4 divided by 5. So I have a 15 divided by 5. That simplifies to 3. So my fractions are gone. I'm left with a 5 times k plus 2 equals 3 times k minus 4. Distribute to get rid of the brackets. Distribute the 5 to the k and the 2. I get 5k plus 10 equals 3k minus 12. 3k minus 12. Collect all the variable terms to one side of the equation. So I'm going to bring this positive 3k to the left. It will become a minus 3k. And I'm going to bring this positive 10 to the right. And it will become a minus 10. So I have 2k equals negative 22. Isolate the variable. So right now I have 2 times k. The opposite of multiplying by 2 is dividing by 2. So to bring the 2 to the other side, I must divide by 2. Negative 22 divided by 2 will give me negative 11. There's my solution. And once again, don't forget you can check by substituting negative 11 in for k into your equation and making sure left side equals right side. Okay, the other way we could solve this question is using a method called cross multiplication. So keep in mind, cross multiplication can only be used if you have 2 rational expressions equal to each other. So it can only be used if you have one fraction equal to another fraction and nothing else. No other terms added or subtracted from either of those fractions. We just have one fraction equal to another fraction, then you can use cross multiplication. Okay? If you have more than 2 expressions, like I was just saying, you have to clear the lowest. You must clear the denominators using lowest common denominators. Okay? By multiplying both sides by lowest common denominator. So this is the only scenario when cross multiplication works. So what we can do here, if I have one fraction equal to the other fraction, I can skip this step here where I'll highlight it here. I can kind of skip this entire step here. You'll notice at this line right here, I had 5 times k plus 2 equals 3 times k minus 4. And if we look back at our question, I've got, if I cross-multiplied, if I did multiply the bottom of one side by the top of the other, 5 times k plus 2, that's this right here, 5 times k plus 2. And if I multiplied the bottom of one side times the top of the other one, I have 3 times k minus 4, and that's what I have right here. So we could jump right to this step and skip this top step right here using cross-multiplication. So let's try that. So I've got one fraction equal to another fraction. So on one side of the equation, do the bottom of one side times the top of the other, 3 times k minus 4. Doesn't matter what side of the equation you put it on. And then on the other side of the equation, do the top of one side times the bottom of the other. So k plus 2 times 5. I'll write it as 5 times k plus 2 because that's the way we're used to seeing it. And now simplify. Distribute your 3. Okay, 3k minus 12 equals 5k plus 10. Collect all your variables to one side and all your constants to the other. I'll collect the constants to the left. So negative 12 minus 10 equals 5k minus 3k. I get negative 22 equals 2k. And divide the 2 to the other side because that's 2 times k. Opposite of multiply my 2 is dividing by 2. So bring the 2 to the other side by dividing by 2. And I get k equals negative 11. So I get the exact same answer as this way. We just kind of got to skip this step here. But make sure you only try and use cross multiplication when you have one fraction equal to another fraction and nothing else. Okay? So for example, for this question, I've got a fraction minus 7 equals a fraction. Can you use cross multiplication for this? Hopefully you came up with the answer of no. You cannot use cross multiplication for this question because it is not simply a fraction equals a fraction. We have this other term here that gets in the way. Okay? So try solving this one using cross multiplication on your own. Pause the video now and try it. Okay, hopefully you've taken the time to try it. I'll show you the answer you should have got for this one. So I have a fraction equals a fraction. No other terms in the way. I can use cross multiplication. So I know cross multiplication tells me to multiply the top of one side of the top from one of the fractions times the bottom of the other fraction and put it on one side of the equation. So 2 times 5 minus 2x. Put that on one side of the equation. On the other side of the equation, do the bottom of the fraction times the top of the other fraction. So 3 times 15x minus 7. Now get rid of your brackets by using the distributive property. I'll get 10 minus 4x is equal to 45x minus 21. Collect all your variable terms to one side of the equation and all your constant terms to the other side of the equation. So I'll have 10 plus 21 on one side of the equation. Bring this negative 21 to the left, it becomes positive 21. And on the other side of the equation, I'll have 45x plus 4x. Bring this negative 4x to the right, it becomes positive 4x. Now simplify. I have 31 equals 49x. I want to get x by itself, divide the 49. So I have 31 over 49 equals x. So there's my answer for this question, 31 over 49, and that can't be simplified any further. Okay. I'm going to show you one other trick, because most people tend to like using cross multiplication. So if we go back to number 4, we could have used cross multiplication for this question if I had have simplified the expression a little bit first. So I'll show you how I can do that. So I have a third times 2x minus 5 equals 3/4 times x minus 2. So a third times 2x minus 5, I could rewrite that as 2x minus 5 over 3. Multiplying by a third, dividing by 3, same thing. And on the other side of the equation, I could have wrote, so I'm multiplying by 3/4. That's the same as multiplying by 3 and dividing by 4. I could have written it like this, so that I have a fraction equals a fraction, and I then could have cross-multiplied. So I'll go ahead and do that actually for you. So what I would have 4 times 2x minus 5 on one side of the equation. And on the other side of the equation, I would have 3 times x minus 2. 3 times 3 times x minus 2. And then from here, just simplify. Get rid of your brackets by distributing the 4. So I have 8x minus 20 equals 3 times 3 is 9 times x minus 2. Then I'll distribute that 9. I get 9x minus 18. Collect your variable terms to one side of the equation, so I'll bring my x's to the right, so that I'm left with a positive x, and I'll bring my constant terms to the left. So I'll have negative 20 plus 18 on the left. That minus 18 becomes plus 18 on the left. And on the right, I'll have 9x minus 8x, because this positive 8x will become a negative 8x on the right. So I'm left with negative 2 equals x. And if you look back, that's the same solution we got doing it the other way, where we eliminated the fraction using finding the lowest common denominator and multiplying both sides of the equation by that lowest common denominator. So either way you would want to do that question is perfectly valid. Whatever you feel more comfortable with is fine. Okay, let's go back. I think we only have a couple more questions to do. Okay, this question, you could actually do this one a couple ways. This is the way I would do this question. I just threw this one in here just so we don't make questions more complicated than they have to be, okay? If you looked at this question, your first instinct, maybe let's just get rid of the fractions by multiplying both sides by the lowest common denominator, and that's fine. Let's do that. Make sure when you're multiplying both sides of the equation by the lowest common denominator, all the terms on both sides have to get multiplied by the lowest common denominator. So I have to, the denominator is 4, so multiply the left side by 4, so 4 times a quarter x plus 3 equals 2 times 4. So I need to distribute this, or I need to multiply both terms by 4. So I need to do 4 times a quarter x plus 4 times 3 equals 2 times 4. So you see how each of the terms on the left side got multiplied by 4. The quarter x gets multiplied by 4, and the 3 gets multiplied by 4. And the other side of the equation has to be multiplied by 4 as well. And what I get, 4 times a quarter x, well, 4 divided by 4, those cancel. I'm just left with x plus 12 equals 8. Isolate the x by moving the plus 12 to the other side. It becomes minus 12. X equals negative 4. Okay? And you can plug that back into your equation and make sure that that is the value of x that makes this equation true. So if we plug that back in, we would get, I'll plug it back in for you here. We would get 1/4 times negative 4 plus 3 equals 2. 1/4 times negative 4. Negative 4 divided by 4 is negative 1. And negative 1 plus 3 is 2. So 2 equals 2. So left side equals right side. That's the correct answer to this question. Okay. So that's a perfectly valid way of doing this question. You could have done this question in a lot simpler way, and I'll show you that way right now. So what I would have done, I would have just isolated the term with the x first by moving this plus 3 to the other side. I would have noticed that if I move this positive 3 to the other side, I could simplify this question. So I have a quarter x equals 2 minus 3. It became a minus 3 on the other side, so I have a quarter x equals 2 minus 3, which is negative 1. A quarter times x, multiplying something by a quarter, is the same as dividing it by 4. So I'm going to rewrite it like this. X over 4 equals negative 1. Now I'm going to isolate this x by moving the 4 to the other side. The opposite of dividing by 4 is multiplying by 4. So to bring it to the other side, I need to multiply by 4. X equals negative 4, because negative 1 times 4 is negative 4. And I get the same answer. And that was probably a lot simpler way of solving this type of question. But me showing you the first way is going to benefit you for doing this next question here. You could try and simplify all these fractions by collecting your like terms right now. It would probably be a lot easier to do this question if we just get rid of the fractions right off the bat by multiplying both sides of the question by the lowest common denominator of all the fractions. So I have 5, 3, and 5 as the denominators of my fractions. Let's get rid of those denominators right off the bat. So the lowest common denominator of 5, 3, and 5 is 15. So I'm going to multiply each of the terms on both sides of the equation by 15. So I need to multiply this term, and that term by 15. So I'll do that. 15 times a fifth m plus 15 times 2/3 plus 15 times -2. So I've multiplied each of those terms by 15. Now I'm going to multiply each of these terms by 15. 15 times m plus 15 times -2/5. And let's go ahead and simplify this now, and then all my fractions will be gone. I have a 15 divided by 5. That will simplify to 3. I have a 15 divided by 3. That will simplify to 5. I have here a 15 divided by 5. That will simplify to 3. So all my fractions are gone now. Let's simplify. So here I have 3m plus 5 times 2, which is 10. 15, so plus 15 times -2, that's -30. So minus 30 equals 15m plus 3 times -2, positive 3 times -2, -6. Now collect all your variable terms to one side of the equation and all your constant terms to the other side of the equation, and then collect your like terms. So I'll bring my variable terms to the right and my constant terms to the left. So it doesn't matter which side you bring them to, either way you'll get the same answer. So I'll leave my constant terms on the left, so 10 minus 30. I'll bring this minus 6 to the left, it'll become plus 6. And on the right, I have my 15m, and I'm going to bring this positive 3m to the right, it'll become negative 3m. Now I have 10 minus 30 will give me -20, plus 6 will give me -14. And 15 minus 3 will give me 12m. Now isolate the m by dividing the 12 to the other side. I have 12 times m. Opposite of multiplying by 12 is dividing by 12. So divide the 12 to the other side. I get m equals -14 over 12. Put that in the simplest form. Those are both even numbers, so I know at least 2 goes into both of them. So divide the top and the bottom by 2. I get -7 over 6. And that is now in simplest form. M equals -7 over 6 is the answer to that question. And you can plug that back in and make sure you've solved it properly. Okay, this will be the last one that we do. Okay, for this one, so I've got 3 fractions again. Step number 1, when you've got all these fractions, just get rid of your fractions by multiplying both sides of the equation by the lowest common denominator. And make sure you multiply each of the terms on both sides by the lowest common denominator. So, my denominators are 2, 2, and 3. The lowest common denominator between 2 and 3 is 6. So let's multiply each of the terms on both sides of the equation by 6. So I multiplied 3 over 2x times 6. I need to multiply x minus 4 over 2 times 6. And I need to multiply the other side of the equation by 6. So 6 times x plus 14 over 3. Now simplifying, our fractions will be gone. 6 divided by 2 is 3. So 6 divided by 2 here is also 3. And 6 divided by 3 is 2. Now let's rewrite this and simplify. So I have 3 times 3x will give me 9x. Plus I have a 3 times x minus 4 is equal to, I have a 2 times x plus 14. Now let's distribute and get rid of our brackets. So I have 9x plus 3x minus 12 is equal to 2x plus 28. collect all your variable terms to one side of the equation. I'll bring them all to the left. So I have a 9x plus a 3x. And I'll bring this positive 2x to the left. It'll become negative 2x. And on the right, I'll have all my constant terms. So I have a 28. And I'll bring this negative 12 to the right. It'll become a positive 12. So I have 9x plus 3x, which gives me 12x. I still need to subtract 2x from that. And I have 28 plus 12 gives me 30. 12x minus 2x is 10x. So 10x equals 30. Now isolate the x. I have 10 times x. The opposite of multiplying by 10 is dividing by 10. So to bring the 10 to the other side, I must divide by 10. So x equals 30 over 10. 30 divided by 10 is 3. So 3 is the solution to that equation. And don't forget, you can plug that back into your equation for x and make sure left side equals right side to make sure that that's the correct solution to the equation. Okay, so that's all the examples I'll do. Make sure you try the worksheet from jensenmath.ca and let me know if you have any questions.